Hey everybody, today you can see the title up on the top of the screen. We're going to work our way through applications of logarithms. And specifically what we're going to address today is when we have an application where we have been given the equation of the function. So I just want to walk through a couple quick examples of us dealing with a logarithmic application where we are given the equation of the function. So take a moment, read what's on your screen, familiarize yourself with the context, and then we're going to work our way through problem A. So pause it now to make sure that we can check out that problem. Okay, we're back. So hopefully you took a look at the problem. You recognize that we have a class. They're going to be tested. They get tested, and then every week thereafter, they're tested on the same material. That function that has been given is what's referred to as a forgetting function. It is the average score in the exam taken after T weeks. So problem A then asks us, what was the average score on the original exam? And so for us to be able to work our way through for the original exam, we should be focusing in on, if it was the original exam, then that means that no time has passed. We should be looking to sub in T equals 0. So we can go ahead and we can do that relatively quickly. That means we are finding G of 0. And so that's a 77 minus 10. You now get ln 0 plus 1, and we should be good. Okay, I am hoping that there is no button pushing going on. Because if I was to make a little note just off to the side, when you take a look at that ln at the end, remember, ln is a log base e. So really what you have in the context of that last log is log 1 from base e, of which you would never write down. But you're really saying to yourself, e to what exponent gives you 1, and therefore that ln value is 0. So I'm hoping that we can see then, while I get rid of that blue, why our calculation would then be 77 minus 10 times 0, of which you'd never have to show me, and we can come right in on 77. So there was the average score on the original exam, a score of 77. Okay, I think you should be very quick to be able to work your way through finding the answer to the second part of the question in A. So pause the video now, give it a shot, we'll see if we match up. Okay, we're back. So whether you thought, hey, T equals 5 as a substitution statement, or whether you thought of it with regards to function notation, hey, I need to sub in 5 for my T. Now, this does become a case where you are going to end up pushing buttons. Ln 6 is not going to be something nice and neat. So we're going to go ahead and we're going to calculate that. I am hoping that we're just following BEDMAS, especially if we have a backwards calculator. But we should be calculating the ln of that 6, multiplying it by a negative 10, and then adding to that our 77. And that is going to get us to an approximate value. And I'm just going to start to write out all the decimals that I might have on my screen, or several of the decimals. I'm just going to go through, depending on what my calculator shows, and just jot down 4. So we get an average score of 59.0824. Now, we've been focusing in on rounding quite a bit during our applications. You take a look back up in the problem, and what we are calculating for this forgetting function is a test average. And there really is no rounding rule when it comes to a test average. You know, it's not like number of people where you have to round to no decimal places, the nearest unit. So for us, our default rounding is our 2 decimal places again. So we should be good to be able to round that off to a 59.08 as our score. If I really care about the rounding, I'll state it in the problem. If I don't care, and there's no inherent rounding rule, then round to 2. Okay, hopefully not too bad. We've been able to hop in, we've been able to work through a couple quick substitutions. Hopefully no difficulty. Now what I want to do is I want to jump into the next problem. Okay, what you see on your screen now, I am asking you how long would it take for a class to have a failing average? Okay, so for us, we would then have to recognize, okay, if we're talking failing average, then we're talking below 50. Below 50. That would mean less than 50%. Oh, wait a second. We've got an inequality. And I maybe want you guys to kind of walk that one back a little bit. Yes, our correct statement could be that G of t must be less than 50%. Which means that you would now be saying that 77 minus 10 ln t plus 1 must be less than 50%. And going, oh shoot, I need to solve a logarithmic inequality. And I'm going to tell you, you don't have to worry about that. That for our process in our course, we could solve this using an equation with a little bit of rounding. So if your thought is the orange, that's outstanding. But instead, I want to simplify it. So I'm going to get rid of that orange with a sense of what we have over on the right. That for us to have a failing average, we need to get below 50. Okay, so the way that I can work through this problem is I can try to find out when am I at 50. So I'm going to focus in on the fact that G of t has to be 50. So let's find out, when does G of t hit 50? Okay, our class average is falling and falling and falling. Well, when do we get like right on the line? Okay, well, if I sub in 50 into my forgetting function, then I get that. Okay, how are we going to solve the equation? First, we have to locate the variable. You see it's on the inside of your log. We got to get it out. So I'm hoping that for a lot of us, our first process may be, let's get rid of that 77 and try to isolate our log. So that's going to give us a negative 27 is equal to negative 10 ln t plus 1. But now I have the coefficient on my log. I do not have a single log. So let's divide out that negative 10. Now, I would get into the habit of writing that. We discussed during exponential growth and decay, sometimes those numbers are not going to work out nice and neat, and we do not want to round partway through a solution. So I need to get used to going through and writing that left side as a fraction. Yes, I could write it as a decimal, 2.7. It is exactly that. There was no rounding. But the second these numbers get uglier, that won't always be the case. So get used to keeping that left side as a fraction. Okay, I've successfully got a single log equal to a number, of which I'm hoping our next action is pretty automatic. Change to exponential. Just remember that you have a ln function, which means you have a log base e. So therefore, you could say the base of e to that exponent gives me that. And there is you changing the blue equation into the brown one. Change it to exponential. You'll notice we are very quick now to be able to solve that thing. I'm going to come up to the right side because now we can isolate our t by subtracting our 1, and we have done no rounding in our solution yet. Okay, now we're going to do a little bit of button pushing. So we need to find on our calculator our e to the x function. When you find your e to the x, Let's get used to being able to punch in a fraction as our exponent. Now we can subtract 1. And I'm going to write down a couple decimal places. So that's going to get me approximately 13.88, whatever units t is in. And you'll notice when you take a look back at the problem, t is in weeks. Okay, so technically what we found is 13.88 weeks. Okay, here's where things maybe get a little complicated, I'm not sure. If I was to write down a time doesn't really have any rounding rules. So if it was just generically time, then because my decimal was something ugly, and I just want to maybe go back and draw upon what you have, that I've already done some rounding to write down 13.88 weeks. That if I actually backtrack that a little bit, what I would have had for an additional decimal place would have been 13.879. And yes, there's then like a 7, blah, 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 blah. But for us just to take a peek at those 3 decimal places, maybe you can see how we got to a failing average. If you look at my orange, that's the most exact answer I can get, like for 3 decimal places, but the most exact answer I can get for t. Now I have to round. That orange, let's just say, is what gets me to exactly 50. Exactly 50%, because that's how we started the problem. Look back up at the top. We set that equal to 50. So if the orange gets me 250 and my average is falling over time, then really what that means is I need to round up. And if I round just a little bit up, I will now have dropped below 50. I will have gone far enough. If I was to draw like, I don't know, a silly little picture off on the side, if I was to say that orange is showing my falling, and at that moment where I just wrote the orange is when I'm at 50, then what I need to do is go just a little bit past 50. And if I just round up, you can see me below the 50 mark. So if you take a look at my brown solution, that 13.88 weeks would represent falling below. Okay, here's where it gets a little complicated. The students are writing a test. And it says that they're going to write a test at the end of every week. So it's not like they're going to write a test at 13.88 weeks, because that's when it gets you 50. No. So really what it becomes then is each t represents a test. We can't write a part of a test. We actually need to round to no decimal places, the nearest unit. And so to simplify that scenario then, we would now round up to 14 weeks, because that would take us below that threshold of 50. I know it's a little complicated with respect to rounding. It is time that we're solving for, but what occurs at each one of those time units is a test. Okay, I want you to take a look at the blue and then how we transition to the brown. And I'm hoping that that's going to help you out with regards to solving some application equations dealing with logs. Okay, remember, the only problems that we're going to be dealing with are going to be when your log function is given to you. So we really got to get used to just manipulating that log function and finding what we need. Okay, your job now, jump in and get some practice. Best of luck.